Year 12. This complex numbers question takes us through some exponential form stuff, and that's pretty recent for us, so I'm going to go really slowly in this video. But the other thing I'm going to do is work all of it through in polar form first, because that's probably the thing you're most familiar with. And if you can do it in polar form, then you can switch it over to exponential form very, very easily at the end. So here we're given a complex number z, and it's defined as follows. So z is this thing here, and then we have to find an expression for z in the form this. We need to have a positive r, a positive modulus, and we need to have an argument theta, which is between negative pi and pi. And then we need to find the two square roots of z, giving our answers in this form. And again, we have to have a positive r and theta between negative pi and pi. So there's nothing hard about that. Theta between negative pi and pi is just our usual thing of not going through the Trump wall. Don't know why that just came up there. Let's just do that properly. So if we want our angle to be between those values, we want it to be around there, from 0 round to pi, or from 0 back around to negative pi. And that's not difficult, right? We can easily switch to make sure this happens. So going right back to the start, we're going to start with this value of z, and I'm going to convert that into polar form. So when we see this, the first thing I want to do is to rationalize or to multiply by the conjugate over the conjugate. So we don't want to have any ugly complex number fractions. So we're going to times the top and bottom by root 3 plus I. So that knowing to do that is kind of an achieved level 3 complex numbers skill if you're thinking about NCEA. So moving through this, we start with the denominator. So we get root 3 times root 3 is 3. These simplify away, and then I've got minus I squared, which gives me minus negative 1. Okay, as I said, I am going to go really slowly on this one. So put it on double speed if you're up to it. Okay, in top line, also called the numerator, right? This gives me 9 times 3. This gives me plus 9 root 3i. This gives me another plus 9 root 3i. And this gives me take away 9. Cleaning all of that up gives me 27 minus 9, which is 18, plus 18 root 3i over 4, which is 9 over 2 plus 9 over 2 root 3i. Now you should spot in there that we've got a special triangle, but it's been scaled up. Okay, so we can very easily here go and get the argument and the modulus. One way to do that is to simply draw my picture. So let's just draw my special triangle picture. I go out 1 here, and I go up root 3 here, and that gives me a modulus of 2. So this length here is 2, and this angle here is pi on 3. And then I'm going to scale it all up by 9 over 2. The other way to see that is to take out that factor of 9 over 2, and then we've got 1 plus root 3i. So if I wanted to draw that again, scaled up, it would look like this. So this side, 9 over 2. This side is 9 over 2 root 3. And this side, it's going to be 9 over 2 times this, times 2. So that gives me that r is equal to 9, and theta is equal to pi on 3. So that means that I can either from here write z as, was it z? I think it was z, yep. I can write z in polar form, which would be 9 cis of pi on 3, or I can straight away write it into exponential form, which is 9e to the pi on 3, or I theta, right? So I times pi on 3. So that's the first part of the question done, and that I think was worth a pretty massive 5 marks, right? And have we got r positive? Yes, r is 9, and we've got theta between those two values. So that's cool. So then the next thing we're going to do is we're going to give the 2 square roots of z, and we're going to do that in exponential form. So most of you watching can probably see the first of the square roots. We've got z is equal to 9, e to the power of theta, sorry, not theta, I times pi on 3. So if I call w what's going to give me the square root, if I square root this, I'll get 3, and I need to halve this power. So it's going to be 3i to the power of I times pi over 6. Right, so that's going to give me one of the square roots. Now, if you think about how this all works when we're working in polar form, that's the same as 3 cis pi on 6. So that's my first square root, and the other one will be evenly situated around here. So you can just about do this question by inspection, but I'm going to show you the clunkier way to do it. So or w is equal to 3 cis, and I'm going to take pi off there, 3 cis negative 5 pi on 6, which is equal to 3e to the I times negative 5 pi on 6. So that's all good if you spot that you can do it just by looking. Now I'm going to do it the other way using de Moivre's theorem. And I'm going to work in polar form. We could start working in exponential form. It's only been a few days since we first saw it. So let w equal r cis theta. So we know that r cis theta squared has got to get me back to z, and z is 9 cis of pi on 3 plus 2n pi. Right, and remember we've gone over that heaps, and I've done lots of other videos and revision worksheets on that. So we get r squared is equal to 9. So here we've got r squared cis 2 theta equals that by de Moivre's theorem. So r squared is equal to 9, r must be positive, so r is equal to 3, since r is greater than 0. And then I've got 2 theta is equal to pi on 3 plus 2n pi. So theta is equal to pi on 6 plus n pi. So that leaves me with my two w's, my two square roots, as 3 cis pi on 6, or 3 cis, and if I sub n equals 1 in here, I'll get one in the form that I don't want. So 3 cis 7 pi on 6, which is around here. I need to rewrite that as negative 5 pi on 6, which is 3 cis negative 5 pi on 6. And now we're ready to really easily chuck them into exponential form. So w is equal to 3e to the I pi on 6, and w to the first w, and the second w, the second root, is equal to e to the power of I negative I times 5 pi on 6. That looks really weird to me, so let's just write it as 3e to the negative 5 pi on 6i. So there you go, 8 marks for that. That's probably one of the most kind of exponential formy questions I've seen in an A-level paper. But if you do still have trouble thinking about it, remember you can always work in polar and then just switcheroo it at the end. Thanks for watching. I'll slowly chug my way through both marking your tests and videoing the remaining questions in the next day or two.